Hey everybody, I am stopping my binge watching marathon of SVU, which is a little traumatic for me because I love SVU, to work on a video. We are coming back from spring break. We have finally finished chapter 8. Man, that was a long one, wasn't it? And we're going to be working on chapter 9. I think you'll like the pace for chapter 9. This week we're going to be working on 9.1 and 9.2, and actually for 9.1 it's just this one slide right here, so pretty much a week of working on 9.2, and on Friday we'll have a quiz. So that's a lot of time to digest the concepts, ask for help, let me know what you're struggling with. I'm sure at some point we'll have a Zoom session and hopefully do really well on our quiz on Friday. We are getting into a chapter about what we call conic sections. And a conic section is, we have a couple of different ones. We have parabolas, which is specifically what we're going to be talking about this week. We have talked about parabolas when we were graphing quadratics, but now we're going to learn some more information about parabolas that we didn't discuss before. We also have circles. I think when we get to circles, you'll really like circles. You'll probably remember, it will seem familiar to you because we did it in geometry last year, but circles are very easy. And then the ellipse is another shape, and I like to think it's a pretty easy shape as well. And then the last one that we have is called a hyperbola. So the way we get these names is we have these cones that you can see in these pictures, and basically it's if you had a plane intersecting a cone, what shape would come out of it. So if you can kind of imagine, oh my dogs, hold on, let me see if I can get them in here so that they stop yapping, because that's the last thing you need to hear in this whole video is yap, yap, yap. Oh my geez. Come on, Tweedledee, Tweedledum. Okay, never mind, they chose not to come in here. But they'll probably still yap, so just ignore that. They're really spoiled. They're not lacking for anything. Back to my picture. So if you can kind of envision a plane, so think about like a piece of paper. If it were to cut through a cone right here, it would form a circle. So if you had a piece of paper that sliced through a cone and it were perpendicular to it, it would create a circle. And then if you look below that, right here, what if that piece of paper that were intersecting that cone kind of shifted a little bit and we're no longer perpendicular? Well, then the shape changes, right? It still kind of looks like a circle, but it's not exactly a circle. That's where the ellipse comes from. And then over here, we have a parabola. If you can envision that a piece of paper sliced through this cone, that's what shape we could get. And then what if the piece of paper sliced through these two cones vertically? We kind of get something that looks like a parabola, but then you get another one down here, and that's called a hyperbola. Hold on, come on, Marley, come in the room because you're gonna bark and annoy me. Come on, go. Oh my heavens. You two rotten dogs. Okay. So really that's all that we're going to talk about in 9.1 is those are the different shapes that you get from a plane intersecting a cone. So let's just jump right on in to 9.2. We're going to break this up into two parts. Today, obviously, we're going to do part 1, and then tomorrow we will get into part 2. So here's part 1. So lots of information for parabolas. We're going to be focusing on parabolas today that open up or down. Tomorrow we'll look at parabolas that open to the left or to the right, and those are going to be brand new for you. But today we're going to focus on just your normal parabolas that open up or down. So here we have a parabola, and we have a standard equation of a parabola that has its vertex at the origin. So we have y equals 1 over 4p times x squared. Well, what does p represent? right down here it tells us. It says that the distance between the vertex and the focus is P, and the distance between the vertex and the directrix is P. So that's some new vocabulary that we haven't talked about. So let's talk about what that is. Well, a focus is a point that your parabola opens around. So see this dot right here that looks like it's inside of the parabola? That is the focus. Your parabola is opening around the focus. Then you have what's called a directrix, and it is a dotted line. In our case, because we have parabolas that are opening up or down, we're going to have a horizontal dotted line, and that's the directrix. Now what this says is that P represents the distance from the vertex to both of these. So from the vertex to the focus is the same distance as the vertex to the directrix. They are the same amount of space away from the vertex. Now back up here, it says that if P is greater than 0, so in other words, if P is positive, it's going to open up. And if P is less than 0, so if P is negative, it's going to open down. And that coincides with what we've learned about with parabolas all along. If you look at the leading coefficient, if it's positive, it opens up. If it's negative, it opens down. So that's not news to us. That's old. Okay, so we've talked about a vertex. Remember, the vertex is either the high or the low point in your parabola, depending on if it's opening up or down. The focus is what your parabola is going to open around. The directrix is going to be that dotted line that's not inside of the parabola. It's on the other side of the parabola. P represents the distance between the vertex and the focus, and the vertex and the directrix. So lots of new vocabulary here for us. So here we have a definition of a parabola. It says a parabola is the set of all points in the plane whose distance to a fixed point, which they're calling the focus, equals its distance to the fixed line, the directrix. That's just the definition of a parabola. Nobody's ever going to ask you to write that definition down or quote it, but there you have it, just in case you're on Jeopardy one day and that question shows up. Now you know. Okay, so let's get into doing some graphing, shall we? So our first example here, we have y equals negative 1/12 x squared. So it says label the vertex, the focus, and the directrix. Okay, so right away, because right now we're just dealing with standard equations with a parabola that has a vertex of 0, 0, so the origin. So right away I know that my vertex is 0, 0. All right, focus and directrix. Well, both of them need to know the value of P. So I'm going to take this negative 1/12, so negative 1/12, and I'm going to set that equal to what the formula says, 1 over 4P. Now, at this point, you want to decide where you want the negative to go. Do you want it to go with the numerator or the denominator? I'm going to stick it with the denominator. It doesn't really matter. It just can't go with both, because if you put it with both, now you've changed it to a positive fraction. So you just pick one where you want it to go. And this is a proportion, and y'all remember back from Algebra 1 that to solve proportions, you're just going to cross multiply. So if I cross multiply, I'm going to get 4P equals negative 12. And if I divide both sides by 4, that means that P is negative 3. So now we know what P is, and not only do we know what P is, but that also tells us that this parabola is going to open down because it's less than 0, and you may have already guessed that because the leading coefficient is negative. So we have a couple ways to determine which way it's going to open down. So here I have my vertex. It's at the origin, 0, 0. Don't forget label your x-axis and your y-axis. All right, so we already have the idea that it's going to open down. So let's talk about that, because we learned up here that the focus is what your parabola opens around. And so what that tells me is that my focus is going to be down here somewhere because I'm opening around it. So P is the distance between the vertex and the focus. All right, so my distance, I'm going to be 3 units away. So I'm going to go from the vertex down 3. 1, 2, 3. And that right there, I'm going to call it capital F for focus, which means that that is the point 0, negative 3. Now I'm going to call this point at 0, 0, I'm going to call it capital V for vertex because they've asked us to label those things. So I've labeled the focus, I've labeled the vertex. The other thing that P tells us is that P is also the distance between the vertex and the directrix. Now remember what we learned, the directrix is not going to touch the parabola at all. So if my parabola is going to be opening down, then that means my directrix needs to be up. So again, from here, I'm going to go 3 spaces, but instead of going 3 spaces down, I'm going to go 3 spaces up. So 1, 2, 3. And remember, this is where I'm going to draw a dotted horizontal line. And I'm going to write directrix there. Now, just as a refresher here, because it's a horizontal line, its equation is y equals a number. And in this case, it's going to be y equals 3 because it's crossing through the y-axis at positive 3. So again, just as a refresher, the P represents the distance between the vertex and the focus and the vertex and the directrix. Now, we already know that this is going to open down, but it would not be good enough to just draw any shaped parabola down there. So we're going to make a table of values. See if we can get some ordered pairs going for us. So one we already knew is the vertex, right? It was at 0, 0. Now you can plug in any numbers you want for x. You can plug in -2, -1, +1, and +2. That's fine. You can plug in other numbers. Sometimes I like to try to plug in numbers, particularly because I have this fraction here. Maybe if I plug in numbers, certain numbers, it might make that easier to work with. I don't know, but I'm just going to try multiples of 3. I don't know that that's going to make all of my answers come out super nice, but it's worth a shot. So really, you can plug in whatever numbers you want. So if I were to plug in a -6, I'm plugging it in for x. So -6 squared is 36. So now I have 1/12 times 36, which is -3. What happens if I plug in a +6? Well, 6 squared is 36, and I still have -1/12 times 36, which is also -3. That would make sense, right? Because we learned that parabolas have symmetry. So if this is the middle, if I go over the same amount to the left as I do to the right, those y values should be the same. So that makes sense. Let's see what happens plugging in a -3. So again, I'm going to plug it in for x. -3 squared is 9. Now I have -1/12 times 9. This one's not going to give me a whole number, but it's not a bad number. It's just a fraction. It's going to be -3/4. And if I do the same thing down here and I plug in a +3, 3 squared is 9, and I'm still going to multiply that times -1/12, and I'm going to get -3/4. Sorry that my writing is a little slow today. My carpal tunnel is kind of on fire, so I'm going as fast as I can. So let's plot some points. So we have -6, -3. We have -3, -3/4. We have +3, -3/4. And we have +6, -3. So we have a pretty wide parabola. And this is why you can't just draw any old parabola. You have to make sure that your parabola has points that match what they would be if you plug the numbers in. That's why we made a table of values. So not too hard, right? Okay, so next we're going to do the same thing, but we're going to talk about what happens if our parabola is no longer centered at the origin. So the vertex is someplace else. Now we've been dealing with these letters before, with the whole H and K's. And some people, let me go up here real quick. Some people like to write this. They go ahead and solve for y, which is typically what we do, right? We normally like to have y by itself. And they move the K over. So let me show you what that would look like. It would look like this, right? So this year we've dealt a lot with H's and K's. So here, the H, that's a horizontal change. And because it's inside with the function, it's going to be the opposite of what you see. Out here, this is a vertical change. K is going to be exactly what you see. So if you write them this way, then H is the opposite of what you see, and K is exactly what you see. And I personally kind of like to write it that way a little bit better, and that's just a preference for me. If you like it like this, then you can write it like that. So I'm going to leave that decision up to you. I'm probably going to do it the other way though. Okay, so everything is the same. We're still going to be dealing with P. P still represents the distance between the vertex and the focus. It also represents the distance between the vertex and the directrix. So P is not changing. The only thing that is changing in this problem is that our vertex is no longer 0, 0. It is no longer the origin. Oh my gosh, Coco, be quiet. Your vertex is now H, K. That is the only difference. So it's going to change where your focus and directrix are, but if you understand what P means, then this is not difficult. P just means the distance between, sorry, my dog's trying to stand on my shoulders while I'm doing this, and that's definitely making me not focus. Oh my gosh, stop. Okay, so let's just jump into example 2 and go from there and hope the dogs leave me alone. So here we go. First thing I'm just going to do is rewrite this. So I've got y equals negative, no, that's not a negative, is it? See, I need my eyes checked. Okay, y equals 1/2 onto x minus 3 squared minus 2. Stop it. Oh, it's dinner time. That's what it is. Sorry, y'all. Okay, here we go. Let me speed up because I'm taking a really long time because I'm getting so unfocused. Jeez. Here we go. So one thing I can go ahead and tell you is I know what the vertex is going to be because I can identify my H and my K. H is going to be the opposite of what I see, so it's positive 3. K is exactly what I see, so it's negative 2. So I already know my vertex is 3, negative 2. Put a V for vertex. Okay, now let's identify P. So I'm going to take that fraction right there, the 1/2, and I'm going to set it equal to 1 over 4P. Again, that comes from the formula. I'm going to cross multiply. So if I cross multiply, I get 4P equals 2. And if I divide both sides by 4, that means that P is 1/2. So what does that mean? Well, first of all, because it's positive, I already know that my parabola is going to open up. So from my vertex to my focus is going to be 1/2 unit away, and I'm going to go up. So maybe I should move that V a little bit. Let's just put it right here beside it. So 1/2 unit up, which is not very much, right here, that's going to be my focus. So the focus is going to be at 3, negative 1/2, which is the same thing as negative 3/2, because it was 1/2 a space away from the vertex. I hope that makes sense. Now the directrix is also going to be 1/2 a space away, but going in the other direction. So it's going to go down 1/2 a space. So right here, I'm going to draw that dotted line, which is the equation y equals negative 2.5, otherwise known as negative 5 over 2. If you wrote 2.5, that would be fine. Just make sure you have the negative there. All right, I'm going to label that as my directrix. And now we just need the parabola itself. So, need a table of values. Okay, I already know that the vertex is 3, negative 2. So, I'm going to pick some numbers. Now, one thing, and it doesn't really matter what numbers you pick, y'all. Again, you can pick whatever numbers you want. One thing I notice is that this is an even number right here, the 2, right? So if I could make what's in there even, then maybe I can get rid of the fraction. So maybe instead of doing a 2 and a 1, what if I go by 2s? And so maybe I do a 1 and a negative 1, or maybe, and over here I would do a 5 and a 7. Again, you guys can pick whatever numbers you want. You don't have to pick the same numbers I am. You can do the next 2 numbers on either side, and that would be fine. So let's see how this would look. So I have 1/2. All right, now let's look in our parentheses. If I plug in a negative 1, I'm going to get negative 1 minus 3, which is negative 4. Then I'm going to square that, and negative 4 squared is 16. And then don't forget the minus 2. All right, so 1/2 of 16 is 8. 8 minus 2 is 6. Now what should happen, because 7 is 4 units away from 3, and -1 is also 4 units away from 3, is that this should also be a 6, but I'm going to double check it and do the math just in case. So I'm going to plug in a 7. 7 minus 3 is 4. 4 squared is 16. Looks like it's going to work out right. Half of 16 is 8. 8 minus 2 is 6. All right, now let's plug in a 1. So I've still got the fraction out front. Now I'm going to do 1 minus 3, which is -2. -2 squared is 4. All right, half of 4 is 2. 2 minus 2 is 0. This should be the same thing, but let's plug it in and make sure. So 5 minus 3 is 2. 2 squared is 4. Half of 4 is 2. 2 minus 2 is 0. So let's plot some points. So we have -1, 6. We have 1, 0. We have 5, 0. Whoa, that's not a 5. That's a 4, 5. There we go. 5, 0, and then we have 7, 6. So we're connecting those. We're opened around the focus. We have the directrix directly underneath it. Don't forget to label your axes. And there we go. All right, let's keep going. So example 3 says to rewrite the equation in standard vertex form. Then we're going to graph and do the same thing we've been doing. So this adds a little bit more, kind of some stuff we did several chapters ago. So if you'll notice, you've got x's and you also have y's. So what I'm going to go ahead and do to get started, Coco, stop. Sorry, y'all. That is really annoying to me. I'm sure it's annoying to you. I'm going to go ahead and move that y on over to the other side using addition. So I still have the -10, but I added the 6y over. You may be wondering, why did you do that? Well, do you guys remember completing the square? Because that is exactly what we're going to do. Remember, with completing the square, this is where you want to find half of b, then you square it, and whatever you get, you're going to add that to both sides. Because whatever you do to one side of an equation, you have to do to the other. So if b is 4, half of that is 2, then we're going to square it, and that gives us 4. And whatever we do to one side, we have to do to the other. Now, why did we do that? Well, this is now a perfect square trinomial, and it turns into x plus 2 squared. If you have forgotten how to do that quickly, go back and look at the notes for completing the square. I think that was chapter 5. Otherwise, you could do sum and product chart and come up with that, but you should be able to do that much more quickly than having to do a sum and product chart. Over here, we are going to combine the -10 and the +4, and that's going to get us a -6. And then I'm going to take out the 6. I'm probably going to run out of room here. I'm going to take the 6 out as a GCF. That leaves me with y minus 1. Now, what I want is for this to be in that standard form. So I want it to look like this. And right now it's not looking like that. So I have a couple things I have to do. The first thing I'm going to do is I need to get rid of the 6. I need it to be over here. Well, since it's joined to this with multiplication, what do I have to do? I have to divide it. So I'm going to divide both sides by 6. Now I'm going to rewrite this. Instead of putting it all over 6, I'm going to put a 1/6 out in front of it. Does that make sense? The 6 is the denominator. And on the other side, now the 6's cancel, and I have y minus 1. And because I like to write it in the other form, I'm going to move that 1 over to the other side. So I have 1/6 onto x plus 2 squared. I'm going to add the 1 over equals y. So now I have it in that standard form, which means now I can determine what the vertex is. So I want to do h and k. H is the opposite of what I see, so it's going to be a -2. K is exactly what I see, so it's going to be a +1. So -2, +1. That's going to be my vertex. Hopefully everybody is doing okay so far. What do we need now? Well, we need to find out what p is. So we have to take that fraction, 1/6, set it equal to 1 over 4p. We're going to cross multiply. We're going to get 4p equals 6. We're going to divide both sides by 4. which gives me 6 over 4, and that reduces to 3 over 2. So what that tells me, first of all, is that this parabola is going to open up because this is positive, and I'm going to go up 1.5 units to get to the focus. So that puts my focus at -2, comma 1, 2, 2.5, so 5 halves. That's where the focus is going to be. I also know that I'm going to go the opposite direction for the directrix. So I'm going to go down 1.5 units for the directrix. And if I had a ruler, this would look so much nicer. So don't hold that against me, please. And so that would be the equation y equals -1/2. All right, so I have the focus, the vertex. I'm just going to put D for directrix. And now I need a table of values. And I already know the vertex is at -2, comma 1. Again, you can plug in whatever numbers you want. What if we just stick with plugging in the ones that are closest to it? Because some of you might be wondering, can we just do that? That's so much easier. So let's try it. Coco, hush. All right, so let's plug in a -4. I'm going to go to this equation right here that we came up with together, okay? All right, so first of all, I definitely have the 1/6. Now I'm plugging in a -4. -4 plus 2 is -2. -2 squared is 4. And then behind it, I still have the +1. So I have 1/6 times 4, which is going to be 4 over 6. And that reduces to 2/3. And I'm adding it to 1. So that's 1 2/3. Or if you want to change that to mixed number, 5/3. Whatever you want. I'm going to plug in the -3. I already have the 1/6. So -3 plus 2 is -1. -1 squared turns into +1. So I end up with 1/6 plus 1, which is just 1 1/6. All right, let's plug in the -1. -1 plus 2 is 1. 1 squared is 1. Guess what? I'm going to get the same thing. I'm going to get 1 1/6. And then lastly, I'm going to plug in a 0. 0 plus 2 is 2. 2 squared is 4. And I'm going to end up with the same thing that I got when I plugged in the -4 at the top of our table of values, which is 1 2/3. So let's take a look at it. We have -4, comma 1 2/3. We have -3, comma 1 1/6. Then we have the vertex. Then we have -1, comma 1 1/6, and then 0, comma 1 2/3. So it's not a super large parabola, is it? All right, so what I would like for you to do is try example 4. I'm actually going to stop the video, then I'm going to pick up with example 4. I'll show you my work, and then we'll do the last couple of examples together. So don't click on the next video yet. Go ahead and try example 4 first, and then click on the video, and let's see how you did, okay? See you in a couple minutes.